Well, hi, good morning, and thank you so much for joining me in my shop. I'm starting on this very nice looking Philco radio. It's in fantastic shape. A little dusty, but that's okay. It's got a bit of a fracture here in the, looks like somebody's worked on it a little bit, but it's still sticking out. Keep an eye on that. That could catch you could carry this radio. Somehow get your shirt caught on this. Actually, if we look here, and separating a little bit there, but not bad. Sometimes these radios come apart in the corners, but this looks pretty good actually. You can see it has all of its tubes. I have no idea if this radio works or not. For some reason it has a knot tied in the power cord. The power cord is very flexible, and I think it's original. There we go. So that's a little sloppy in there. Loose strands of wire floating around in there. That's not so good. Yeah, this has not been done properly. So we'll redo this at some point. Assuming the cord is good, and it does look to be good. Has a phono input. Has the two antenna wires, antenna wire and a ground wire. I am guessing. Some words here. It's like licensed by Hazeltine Corporation only for use in the home, for educational purposes or for private non-commercial use. Patented 24 to 39, 1939. It's a Philco. I can't really read the model number here. I have to put the close-up camera on that. Looks like it has a adjustment right here for something. It has an unusual, not unusual, but varying types of tubes. You got a type like this, and we've got one like this, and then we got a glass one here. And there's probably been some tube replacement in here. 1, 2, 3, 4, 5 tubes. I think there's no empty socket. I see one IF can up here. The power transformer is located in the center of the chassis, which is very unusual. You usually put it off to one side. Looks like a sheet of asbestos across the bottom here. Some information up here. It's a warning to not operate it without a license. And the tubes, so these are so the 6A8, 7A7, 6Q7. This doesn't add up at all, I don't think. 7A, 7E. A 7. Well, a 7 means a loctal. So yeah, so that's a loctal. A loctal is a type of tube that was made so the tube actually locks into the socket. Particularly good in car radios to lock the tube in so it won't shake loose over time. And it looks like there's two loctals here. This is 7A7, and then the next one 7B5 here. So it's kind of an odd, it's an odd combination of tubes, because we've got one metal tube, two large glass tubes. What does it say for this one? This one is a 6A8. And this has got to be the rectifier tube, and it's a number 80, it looks like, a very common rectifier tube. So a bit of an oddball radio. Transformer in the middle, loctal tubes, but only two. Look at the front, has an interesting, really interesting speaker grill area there. It's kind of a I'm sure there's a word for that style of art, but I don't know what it would be. And we've got a nice dial here. The plastic is in great shape. and the dial pointer and everything. With the AM radio across the top. And what's going on underneath? Oh, yeah, I thought this was a shortwave band, but I don't think so now. I think this is an AM only radio, and across the top it's showing the frequency you're tuning to, and at the bottom it's showing you the wavelength of the wave you're tuning to. So that would make sense. At 550 kilohertz is equivalent to roughly 550 meters. I want to say meters, but I'm not sure what this wavelength would be. Yeah, it says right there, meters, marked in meters. Where was this radio made? This radio was made in. Well, I'll get the close-up camera. We'll take a look at where all that stuff on the back again. Here. Now, this camera has an annoying autofocus, so I'm going to shut off the autofocus here. It hunts a lot, especially with the patterned surfaces. If you show the camera a patterned surface, it wants to hunt up and down. So there. So we got a good look right away here. Let me just turn something on here. There we go. Okay. Sorry, got a little preoccupied with the computer. So we see it's the Philco model number 32. Code number 121. So that's kind of like the chassis number, I believe. For the production run, 50 to 60 cycles, 35 watts. Patented. Licensed by the Canadian Radio Patents Limited. So there's this patent thing that happened in both the United States and I guess here in Canada, where the radio patents were collected up and put under one corporation, which then kind of rented them out. Something like that. I probably don't have the story right, but that's where RCA came from, I believe. Maybe I have the story all messed up because I've never really read it anywhere clearly. But so if you wanted to make a radio, you had to, and you're going to use a patented approach, you're going to have to deal with RCA, or in Canada here, the Canadian Radio Patents Limited. 1915 to 1930. Now this radio would be from around 1930, 32, somewhere in there. What's that? B6282. What's that number? Licensed by the Hazeltine Corporation. This is what I read before. Here the patent number goes up to 39. That would put this radio in 1939 with these kinds of tubes. Well, this kind of tube, the Lochtel type tube, it's a fairly new thing. Philco, I didn't realize that they were Philco tubes. That explains why they're in a Philco radio. So where'd they make this? Radio Telephone Broadcast Patented, made in Canada, Philco Products Limited, Toronto, Canada. So this was made in Toronto. Okay, it has the worn out sticker from our power company saying this is okay to plug in the wall. This radio will serve as a fine phonograph. Connect a Philco record player here. Right there. Always be selling, I guess. So here's the asbestos sheet. I tend to remove these from the radios and dispose of them. Here where I am, a sheet like this is disposed of by just sticking it in a plastic bag and sticking the plastic bag in a plastic bag and then throwing it into the regular garbage. Now, is that a dead animal there? It would kind of look like, I think I saw his brother. Oh no, that's just a piece of dirt. Okay, I don't think there's too much more to see. Should we just try operating this radio as it is? No, look way up in here. I can't see anything. Well, I kind of like doing that. Perhaps someone else has already restored this radio, and there's nothing at all wrong with it, and it's actually raring to go here. Oh yeah, I was going to fix this. Yeah, let's fix this. So the problem here is the strands. You can see a strand sticking out this way. A little one here. Two things about those strands. One is obviously they can short, but I think more importantly, and this kind of plug is really terrible. Look at this. It's all cracked here. You know what? We got to replace this plug. It's cracked. This is just too risky. Trying to put this in and not touch them. These little wires are going to come out around here. This is Bert, in case you haven't met me. Cat, you almost fell off there. What happened? Cats don't fall a lot. So we're going to replace this. I have a nice new, rather ugly plug here we can use. Right here. $1.29, true value. Oh, okay. Some strings here. Don't eat the wire. I'm talking to my cat, by the way. I was not talking to you. Okay, what we'll do is put a little bit of some solder on here to make sure to basically to trap all the strands. Let me give you the cat view of things here. He's moved right in this morning. Are you laying on the solder? Is there a chance you're laying on the solder? No, I have it. But you are laying on the... No, you're not. Don't bite that. There's a trick to putting a wire under a screw. It's not a secret or anything. You want to put it under the screw so as you tighten the screw, it pulls the wire under further. That would be this direction here. This is a unpolarized plug I'm putting on. Let's use this big one. Go. There's a bunch of strands. Did not get soldered. This only got partially soldered. There we go. What did you see there that interested you? There's another one right out here. You helping, are you? Don't get too close to a screwdriver. Jab ya. Okay, that string. She's good. Okay, put this back in. You're chewing my nice handle, you know. Hopefully these tools are cat proof. Well, I think maybe after having done this plug, I kind of have to plug the radio in now. Kind of white plug on a brown cord. Okay, you know what? I don't want you biting through this, because this is important insulation here. It protects me. Now you chew through it, and I have to get a new pair. Talking about a new pair, you lost your pair, didn't you? Okay. So plugging this out, I wouldn't plug this right into a regular wall outlet. That would be just a little too risky. I'm going to plug it into something that I can control the amount of electricity reaching the radio. And that's something called a dim bulb system, although system is a bit of a strong word for it. I have two incandescent lights here, one here, one here. They're both screwed in. I'm going to unscrew one of them here. The idea is quite simple. Throw this switch down, power gets to the radio from here through the light bulb. Whoops, through the light bulb. If I throw the switch up, then the power comes straight from the nuclear power plant about 150 kilometers from here, straight into the radio. So down protects the radio because the power is coming through the light. If there's a short in the radio, all that happens is the light gets all the voltage, and the light is very, very bright. The light is very good because if something goes wrong, whoosh, you get this light blasting me in the face. I can't miss it. If I have a little meter indicating over here, I can miss that easily. So, but I like the dim bulb. Dim bulb works good for me. Okay, we're just gonna neaten things up here a wee bit. I also, you must have seen, I also have this device which has a dial on the front. It should be set about there. And I can ramp up and down the voltage with this. But I really like the light bulbs. What is going on out here? We have a cat fight forming behind us. Let us observe the cats. Oh, the fight's over already. So that's my black cat out there, Shadow, and she doesn't get along with these guys. Not really. They get along with her as much as they can. But she's waiting for me, you see. And I'm gonna go and let her out of the garage door. How would that be? Oh, you're here too. Shadow, come on. Come on. Oh. No. What? Okay. Shadow does not appear on my videos very often, so here she is. You can see why right away. Why she doesn't. She's just struggling like her out. Okay. Now she's really upset. This is one upset cat here now. What? What is it? Hey. Hey. Okay, I have to go upstairs and let her outside, I think. There you go, that's some cat excitement. Just before we turn on the radio, when I come back, we'll turn on this radio and have a different kind of excitement here. Okay, let's practice a bit. Not a lot to practice with. 2 knobs. Volume, on off switch, switched off now. And the tuning works. Great, we're going to tune it in and around this area where there's stations. I have an antenna connected. This cable runs to an outdoor amplified antenna. So it's a very strong radio signals here. Any radio can pick them up. This guy here, the plug, is energized with these 2 switches. This one, I told you, went down to pass current through the light bulbs, up straight to the nuclear plant from here. Actually 2 nuclear plants sharing the load here. This guy just turns everything on and off, so we're on. If I flip this down, we'll be able to read the power on here, the voltage rather on here. But this is not turned on yet. Let's hope. Okay, so you may have seen a couple things happen. You see this meter pop up. This is an inaccurate meter, but it shows that there's voltage here, but this is really the accurate thing. 107 volts waiting. So we're going to turn this up just a little bit. So 110, 111 volts, that's normal. Now it is going through the light bulbs. So when I turn the switch on here, the lights will come on. There's a pattern to this too. When you first turn it on, the radio's cold, the heating elements in the tubes are cold, a lot of current rushes through them. When the current rushes in, the light gets bright. So for the first bit, when I snap it on, what we should see is the light becomes quite bright and then dims down fairly quickly to a fairly low level. Depends how many tubes are in the radio, how many bulbs I have screwed in over here, how much you can see this. In fact, did I loosen? Yeah, I've loosened 1 bulb. So all power is going through this light bulb here. I think that's a 40-watt light bulb, I think. Maybe a 60, I'm not sure. So after the heaters heat up, after just a few seconds, and the light brightness has come down, it will then start going up. It's going up because the tubes are heating up fully now and starting to conduct their own current. the whole radio is starting to operate. It takes, 15-20 seconds for a tube radio to warm up. This is what's happening during that time. As you see the light bulb getting brighter and the radio's drawing more and more current, at some point you'll start hearing something come out of the speaker. Could be noise, could be crackle, could be hum. For a radio like this, might just be one big whopping hum. There's even a chance when I first turn it on, right from the start, boom, this thing is humming. We will see. Most old radios have problems with their power supply filter capacitors, and the result is a hum. If everything's in good shape, maybe somebody's already done work on this radio, I don't know. The brightness of the bulb will come up to a certain point and stop. This thing will register probably 90 volts or something of that sort, and the radio will be working, maybe not at 90 volts, something like that. I may have to jack up the voltage a bit to make the radio work, who knows. If there's something wrong with the radio, this light won't behave the way I've just described. So we're all set to go. You can watch this thing too. Here we go. Okay, on, going down, coming back up. That was pretty quick. 71 volts. I hear a faint hum. 80 volts is very low for a radio like this. I wouldn't expect it to work. We're going to give it a fair bit of time. It takes a long time for the heaters to heat up when you're restricting the power to the radio. Nothing coming out yet, so we're gonna raise up the voltage here. What I'm going to do is I'm going to screw in the other light bulb. That'll provide two, they're in parallel, those light bulbs. So that'll provide two paths for the current to make it over here. A lot more current will make it here. This voltage will go up. Can I stand this here like this? The voltage will go up probably almost to normal. Let's see what happens here. And the radio may start working. Okay, the hum got a little louder. Coming up to 93 volts. Usually these radios work at 90 volts. So I'm going to push this up to like 100 volts now. So we're just over 100 volts. A little touch higher. Radio should be operating. The hum is not dramatic. And it's not receiving anything at all. Oh, my meter's bouncing down here. Okay, so something's wrong with this radio. Guess what? There's something wrong with this radio. Okay, let's get it out of the chassis and do a little inspection on it. And I'm not going to start working on it today. We're just going to look at it and sort of plan out how to approach it. Well, actually, I have no idea what I'm going to do next. That's the truth of it. You never know where the points of interest are going to come. So, nothing too interesting about the bottom of this radio except up here. It's got two additional screws countersunk into it. Countersunk so they don't protrude, I guess, but that's pretty deeply countersunk. I'm guessing there's another screw here. So I'm guessing somebody's trying to screw this corner together with these screws. That's my guess on that. What did it say here? 29. And then somebody's just got some kind of fancy mark they make there. That's probably, I'm going to guess, that's the guy who did the woodwork on this, although I don't know. I don't know how they make these. It would be one guy building this cabinet, or it would be an assembly line of cabinet making. Okay, so I'm going to take out these three screws. We can start with the low one here. Oh my gosh, nothing holding that in at all. Aren't the right screws. Well, that's part of the story there. How'd they get to be the wrong screws? Yeah, these can't be correct. I mean, somebody's been into this thing and they lost the screws. Okay, if that's true, you know, if my story is true. Now, sometimes there's stuff up in here that the radio can get hooked on when you're taking it out. There's nothing up there at all. Okay, here we go. Out you go. I don't want to bring the asbestos sheet. Did I not take the knob off the front? Usually I like to grab these radios by their power supply, but it's a little tricky. Or the transformer, it's a little tricky with this one. I've got enough to do this here. Out you come. Wow. Wow. Not much clearance here. Oh, I see some interesting stuff already. Right away. Look at, can you see the dial string there? Let me. It's a piece of ordinary kitchen string. That's not correct. It's crossed over here, which is a little unusual, but I tuned the radio and it did tune correctly. It's probably crossed over here because he wrapped it incorrectly on this knob. He wrapped it the wrong way. Whoever did that, somebody did that. Okay, now. Here's the exciting part. We'll look underneath. Oh, I just put my finger through the speaker. Oh, man, look how stupid of me. Ugh. Ugh. Just one like that. Duh. Okay. Almost put my other finger through it. Front. Here we are. Wow. Well, nobody's done much down here, I don't think. I mean, these are original. All these wax ones, they look to be in pretty good shape, actually. It generally looks to be in good shape underneath here. These blue filter capacitors are, they may not be original. They could be replacements. This looks resoldered, but it's hard to say. Yeah, I don't think it's hard to say. I can see that this capacitor, the one down here, the way they've soldered it here, it almost looks like they just tack soldered. They laid the wire up to the side here. Excuse my cat. They just laid the wire up here. Oh, he's on my keyboard. Are we still running? So these are probably replacements. Now, is there a big tall one on the top? Big tall capacitor up on top? Or anything missing? No. So the original filter capacitors must have been fairly small, style like this. Am I absolutely sure about this? No. So you see how they've made power cord connection straight to the primary wire here and done it with a taped connection. And they've used what we in Canada call hockey tape, but this I think is commonly called friction tape. And that tape is good. That tape lasts. Look at it. You use the standard electrical stuff, this vinyl stuff, and unless it's expensive, if it's cheap stuff, by after a few years, it just loses its stickiness and just unwinds. So this old tape is actually pretty good. What are you doing back here? Oh my gosh, look where he is now. Like you're gonna fall, God. Even though you got 4 feet, doesn't mean you can't. Always going for the microphone. Here we go. This is this new thing. He loves my microphone setup here. He likes to play with it. You can't do this, okay? Like almost every video now, I have to do this with you. tour of my shop. What are you doing now? You can tell where he is because of his tail. See? There he is. Oh my gosh. I have to keep an eye on him while he's up there. I can't continue. And I can't just grab him for obvious reasons. We can get him now. Okay, come on. Come on. Don't resist. No resistance. Futile. Ooh, I got him up in the air. Okay, bird machine, you're going down. Don't go up there. No going up there. That's what he says. A bit of a spider in there. Why didn't this work? It may not have worked because of a dead tube. That may be the first thing we should look for. I have a little bit of asbestos here, which I'm going to get rid of in the meantime, and then we'll test the tubes. I think that's the best thing to do right off the bat. Because people feel such a concern about asbestos, I'll show you, excuse me, what I do. Wet it. Once it's wet, the fibers won't float off. And then because it's just kind of stuck in the corrosion of the surface of this metal, you just scrape it away like this. And like I say, where I live, this kind of asbestos we dispose of in the regular garbage inside 2 plastic bags. This is a very small amount of asbestos here. The people who really suffered from asbestos were the ones who worked with it, who installed it as insulation or removed it from buildings, or got it, it was in the way type thing, so they took it down. That kind of stuff. Asbestos was a big product here in Canada because we have a lot of it in Quebec, I believe. So unfortunately, I believe Canada had outlawed one kind of asbestos and was still selling that kind to other countries that hadn't outlawed it. Isn't that that's kind of a bad thing, isn't it? Is there any other? Nowhere else did it stick, just on this one, which is good because usually you find the stuff all over the place. Now, of course, it could be fibers that have floated free, and they are floating around my shop right now. Do I need to be concerned about that? Probably at my age, no. I'm just cleaning up a few bits and pieces here. Stuff that's here and there. Spider webs and stuff. Okay. As for the asbestos sheet, oh, look at the asbestos sheet in there. It's more than just an asbestos sheet. It's an asbestos sheet with a metal cover. That looks like a spider house. Oh no, that's not metal. That's cardboard. That's cardboard. I mean, the reason for having the asbestos there is so you can have a little fire in the chassis and it won't set the wood on fire. It's a wooden radio. For crying out loud, you put a sheet of cardboard in there and you're putting in your kindling. Seems a little counterproductive to me to have done that. Okay, so we're going to test these tubes. Okay, I'm going to clean the radio up a little bit too. We might as well start with a rectifier tube here. Number 80, very, very common rectifier tube in old radios. It's very large because it gets hot, and the large glass bulb, I guess, keeps the outside glass temperature lower. It's still way too hot to touch. You do not want to touch one of these when they're warmed up. Okay, number 80 right there. We're going to test it on my Weston tube tester here. I'm going to get the camera into a better position, a little better lighting setup. Okay, I think we're ready. Let's see, I've set this up for number 80. It's a rectifier tube, and like most rectifier tubes, 5 volts on the filament. This doesn't matter. This doesn't matter. The numbers are 73P00, 73P00, 6000, 6000, 25E. Very good. We're all set. 2 pins are bigger than the others. These are the heater pins. Right there. Okay, I can see it's heating up already. Check the line. This is a heavy tube, draws out a fair bit of current. Let me throw the line down a little bit so we'll reset it for an accurate reading. Next check is for leaks. In this particular tube tester, leaks are shown right up on the meter. No. But on number 1, it should go all the way over. And there's a warning down here, F. F means when you hit number 1 here, the meter will go over. So that's normal. There are two tests, a P1 and a P2. Plate 1, plate 2. We're on plate 1. We're ready for the test. We're going to flip the rectifier switch here. The rectifiers are okay if they pass where my finger is now. Okay, and plate number 2. There's nothing wrong with this tube. It's good. Number 80. Okay, I'm putting that back in. We'll just pull the next one out here. So this has a completely different base. This is the Philco base, and you can see this center post has a bump in it. Plugs in, bumps in. That's this one here. There's still a key on the center pin for the turning of it. This is a 7B5. The 7 doesn't mean 7 volts. The 7 actually means 6.3 volts. Well, when they numbered these tubes, they wanted these Philco ones to be identified by the number. So rather than call this a 6B5, they used a 7. And it's just to identify the tube. So when you see a 7 something something, it's a Philco tube, not a 7 volt tube. Okay, let's find it. 7, what did I say it was? 7B5. 7B5. Oh, here we are. 7. Ooh, it's right at the end of the roll. There's 7B5. Okay, so we got it. So 6.3. Signal level 2. That's it. The bias is 19L. L for low, I guess. 19. The numbers are 73001, 73001, 5160, 5160, 37, 7B5. I just set it up for a 7B4. Okay, I think I switched partway through here. So 2 right here, 49H. This should be 49. That's a big difference. 49H. That's just about as high as it can go. 46H. 73400. Totally different number. 73400. 5160. 5160. 40. Yeah. There's 2 tests in this tube. The first test is for the triode. Just double checking now. 6.3, 2, 46H, 73400, 73400, 5160, 5160, 40 F. Okay. There we are. Okay, it's definitely heated up. Okay, looking for leaks. Now there's no indication here. There should be, should show no leaks at any time. Good. Pushing the GM test. This tube should come up to 680. 680 is only about here. If it can't get past my finger, it's time to change the tube. That's way up there. She's a beauty. Now there's another test for another part, which is the diode. Take the tube out for this. 70003. 70003. P160. P160. 48 A. Two diodes. So there's a plate 1 and a plate 2. Put this back in. Cats have come to disturb me again. Okay, that's in, Jim. Don't overdo it. You're going to jump right up here? What are you going to do? What's the problem? Have you got nothing to play with? I don't think there's a toy in here, Bert. No, I don't think so. I don't think I have any cat toys in here. Oh, he thinks I'm leaving. Off he went. Okay, this is definitely warmed up. No shorts. And in this case, so this is a diode, so we're pushing this. It has to only come up above my finger here. Oh, what happened? Drop it. P2. Oh my gosh. Well, we have a defective diode in this tube. Let's just check a few things before we conclude that. 70003. 70003. P160. P160. 48. That doesn't really matter for this. So I think we actually found a bad tube here. One diode's working. The other diode is not. Let's wiggle the tube a bit. She's a dud. Okay, well that's interesting. 7B5. So that's one tube down. Okay, you know, I'm going to take a little break here myself. I drink some coffee. So we've done this tube and this one, which I will clean for no good reason. And the next one will be this one. This is a 6Q7. This is a busy tube. Wait a minute. Wait a minute. That's just a little odd. Isn't this the detector tube? Where'd he go? Where'd he go? Where'd you go? He's just a wildcat here. See? Wild. He's going wild. Where's your brother? He decided the camera tripod's a good thing to scratch himself on. Okay, buddy. You really do distract me, you know. Come on. There's his other end. Okay, stop looking for trouble to get into, and come on, we're gonna go and I'm going to drink coffee. You can come with me while I drink some coffee here. And we continue the tube testing. Let's take a look at the radar since it's just starting to rain outside. I live right here. You can see the storms are coming. Let me zoom in a bit here. This is the Canadian weather radar. So there's where I live, right there. And yeah, this light stuff almost never, you don't actually see any water hitting the ground. It's this stuff here that's actually got rainfall in it. Okay, that's what's coming. Let's look at the American version of this, which they're kind enough to let me look at. And so again, I live right in here. And what happened? It stopped rolling. There it goes. So anyway, you can see, yeah, here's the heavy stuff coming. Okay, that's the weather report for me. I was just cleaning the top of the tube here like this, and I just bumped the wire, and the grid cap just fell right off. These are made of steel, so they have some springiness, so they can grab the grid cap. Oh, it's a loose tube. It's not grabbing it. And you can't solder a wire to steel, so what they do is they shove the wire in here, and then they crimp this down on it. And those connections are troublesome. Sometimes there's solder over them. This one I don't think there is. It doesn't look like it. It literally looks like either the wire broke right here, or it actually pulled out, because there's a lot of bare wire up here. Anyway, that's what's happened here. Okay, I'm getting the next tube ready. I was wondering, this guy has diodes in it. Doesn't this one too? A 6SQ7? We'll have to look at the schematic to sort that out, but something seems kind of weird to me. It seems like this tube, this one here, and this tube doing the same job. Why would there be two of them? So I'm probably just mistaken about that. 6Q7. QRS11. 6Q7. Yep. Right here, 6.3, signal level 1, 23L. 27300 27300 0610 0610 30 F. Grid cap 6.3. Grid cap. Okay. So, and the question would be, if this tube has one diode not working, is it necessarily a problem for the radio? We'll have to look at the schematic again, because I don't quite follow why we've got one of these and one of those in the same radio. That seems just a little odd to me. Okay, you might have some trouble seeing the pointer, but I'll tell you what happens. When we look for shorts, there are none. This tube, this test, should come above 780, so above here, way above, way up here. Okay, that's one test. Now there's another test, similar to the last tube. We're now going to do the diode test. 2703P, 2703P, 0610, 0610. Hold on. 2703P, 2703P. I thought I read the wrong line there. 48. A. P1, P2. So you see it says plate voltage. Low and high. So I'm doing a detector tube, low. Actually, I'm doing a diode, so low voltage is good. 48, P1, P2. Put it back in. Grid cap may have no effect in this particular test. We're just testing two diodes. Give it a moment to warm up. Okay. No shorts. This time we're pushing the diode button. Diode's okay here. Diode's okay, and then plate number 2, is that not correct? So this tube is good. Both diodes are good. We can't figure out what's going on in this radio until I check out the. So I'm going to put this one back in. Put the good one back in. Good ones back in. Keep the bad one out. We're on to the next one here. You know, there is a way of taking these tubes out. Let's just try it. The idea is you're supposed to tip it. Tip it a certain way. Tip it towards the rivet, or away from the rivet, and then pop out. I need to practice. Special technique. I think the main thing with these tubes, what you do not want to do is just grab them by the glass bulb and yank and twist and yank. These particular tubes may be rugged, but some of the others, you know, cause some damage. Okay, the tube is 7A7E with an E on the end. I wonder what the E is for. Export, what would the E be for? (7A7). So we'll look for 7A7 right there. So 6.3, signal level 2, 29L, 73421. 73421. 73421. 73421. 5160. 5160. 44 C. Okay. One test on a 7A7. Here we go. Even though these tubes lock in, when you put them in, they don't feel like they're snapping in place. They don't get a good feeling when you put them in. I don't get a good feeling anyway. Okay. Any shorts in you? No. So this tube, the 7A7, 1350. So this one, it's got to come up to about this high, or it's considered bad. Ooh, wow, that would be considered bad. That's for sure. Okay, double check everything. 7A7 to 29L 73421. 73421. 5160. 5160. 44 C. Oh. Look at this. That's the tube working. It's coming up around 2000. I think it's okay. I think it's okay. Okay, now one more tube to do here. When I'm testing a tube and it comes back bad, I don't, as you can see, I don't immediately go, oh, throw that guy away. I start thinking, oh, there's something wrong with the test, or done something wrong. I don't want to condemn tubes too quickly. This one was not set all the way down in the socket. (6A8) has some kind of shielding on it, like sprayed on the inside of the tube. I think that's inside. This material, all inside. Okay. 6A8. Let's give them a go. 6A8. A8, here we are. 6.3, signal level 1, 20L on the bias. 27345. 27345. 4610. 4610. 32. C, that's where that is. Grid cap, whole tube. Whole tube. So I think when it says whole tube, what they're telling you is there's a couple functions in the tube, and it's testing them all at once. I think that's what they're trying to say. 6A8. Yeah, this will be the mixer tube. So it has two signal grids, like a grid for the local oscillator and a grid for the antenna signal. And so they're just telling you they're doing the whole thing at once. In we go. Okay, and grid cap on. So far we found all these tubes to be good except for one diode in the Loctal tube. Well, like I say, we'll have to look at the schematic to understand what is going on, if that's a cause of the dead radio. Okay, this tube, 6A8, should read 750. 750 is about here. And she's way up. So tubes are very good in this radio. So I really think the next step is we need to look at the schematic. Gonna need one anyway, so I might as well hunt one down. This won't set all the way down. Hey, what's going on there? Ooh, really something holding it back. Maybe some solder in the socket. So this is the one guy. Look at the grid cap wire. It wants to go back there so bad, even though the cap is here. You know, a solution to this, which real simple solution I'm going to do right now, use this to clamp the wire onto the tube. Yeah, that's not bad. That's not a bad solution right there. Rather than try to crimp this wire back in here or solder onto the steel or whatever it is, this is actually not too bad. Okay, great. I'm going to put this tube in, and we're going to hunt down a schematic and see what we can see. I'm going to hunt down the schematic. So this is from a website called Pacific TV. It's out on the west coast of Canada, and they have a great collection of Canadian schematics, including this one, Philco Model 32. So we'll just whip through here really quick. AC operated heterodyne receiver, automatic volume control, pentode output, and electrodynamic speaker. None of that's too exciting, really. They're proud of it, but it's not too exciting. Here's the tubes. They are the ones I've been testing. We have an alignment of compensators. Alignment of compensators. We don't need to worry about this yet. Here we are, the schematic. What is going on? So this is the output tube. Why did I have to do multiple tests on it? It's just a regular amplifier tube. So this is the one with the diodes in it. Well, why was I was testing diodes on this? Something wrong here. 7B5, and it says on the tube 7B5. What did I do in the tube tester? Maybe I had it set for the wrong tube. That's weird. Okay, maybe I must have tested the wrong tube. 7B5. I'm gonna have to check that out. Otherwise, we won't go through this right now. Let's just go check that tube out. I think I've encountered an error in the listing on here. So here's a 7B5 in my book. It says 7B5, glass lock-in type, using the output stages of radio receivers. And look at it. It's got a suppressor, it's got a screen, it's got the signal grid. You know, it's a pretty normal looking tube. But there's no diode in there. But look at my settings here. 7B5. And I'll try blocking that bit of light there if I can. So 7B5, there's two sets of tests. The second test, the D there, stands for diode. And see where it says P1, P2. It's thinking there's two diode plates inside this tube. What am I doing wrong here? 7B5. I can't have that wrong. I'm looking right at it. You're looking right at it. Something weird about this. So, conceivably, I have not tested the output tube. That the test in this particular tester is just completely bogus. 7B5. I got to get another tube tester here, and we'll compare it. We'll compare the. Maybe I can use another tube tester to test the tube. That's really strange. Strange stuff happens when you do this work. Okay, I brought out my favorite tube tester here. It's a very popular tube tester back in the day, in this part of the world anyway, here in Canada. It was a Stark 966, pretty happy to have this guy. And he's been a hard worker for me. There we go, lights on. And we're going to grab this tube out of the radio here. Let me use the technique to get it out. I did. Okay, 7, just read it off the tube, 7B5. There can be no question about that, 7B5. 7B, right at the end here again, oh, 7B5 right there. 6.3 volts, the heater is JR. The pins are 6237. 6237 with a 0 on the end. 34. It's right there already. And 68. That's interesting. It's right there. Press P4. The reading should be 1010 at the lowest, and 1600 would be like a new tube. So this is a replace 1010. Look, there's only one test. There's no talk of diodes. My other tube tester has something wrong in it. 7B5. Okay, we'll pop this guy in. Just wait. Yeah, 6.3. So over here is the scale setting for the meter. And it's got 4 scales, 3,000, 6,000, 15,000, and another one, English. If you flip it to English, then you're just reading the replace and good. Everything is calibrated for replace and good. And this is the control that calibrates the English. But I usually like to leave it on a number setting. So this is the 3,000 scale. This particular tube is between 1,000 and 1,500. So the 3,000 scale is good. It's going to be in this area here. Something like that. Okay, ready to do the shorts test. Unlike my other tester, this one has a light. It says shorts. So you just watch this light as I go through the different. Flashing is fine. It stays on. Not fine. Good. So push P4 and we expect this to come up in this range here. I say it's way up in the good. We put it on English. Check the English setting. I never do this, but I'll do it for fun. Just for fun. The English setting is 68. So it's at 68. What does it say in English? Good one. Okay, so despite the previous test and the weirdness in my other tube tester, which I still can't believe. I can't believe it. So we didn't find any bad tubes here. Did we? We didn't. Did we? Huh. Phooey. I was kind of excited. We had one bad tube. That can explain the dead radio. Well, this is mighty strange stuff here with these tube testers. There's probably a bulletin. If it's true that the other tester is wrong, probably a bulletin on it somewhere. 7B5. I can't be reading this wrong. And there's the 2 tests. She's wrong. My gosh. Is there nothing in this world we can rely on? Nothing. Not even tube tester data sheets. Okay. I think we're going to leave it at that today. Tomorrow we'll pursue the question of why isn't this radio working, and we'll try to track down a specific problem if we can and eliminate it. And then once the radio is operating with a minimal amount of effort by me to get it there, then I'm much more comfortable with going in and changing capacitors and messing around with it. If it's not operating, then you don't really know what's happening as you work on it. So if you have an inoperative radio and you think, oh, I'll just change all the capacitors and then it'll be thumbs up. Well, you change all those capacitors and it's still not thumbs up and you don't know it, but you made 2 mistakes while you were doing it. You got no way to know it. Now you got a radio that's wired differently because of the mistakes you've made from the schematic. Wow, you got a big challenge on your hands if you do that. So that's kind of called shotgunning. That's the word people like to use for it. Just go in and change all the capacitors right away and then see what happens. That's not, certainly not my policy, that's for sure. Okay. That's it for today. It's an indoor day for me because of the rain that's out there, but that's fine too. It's not so hot today. Thanks a lot for watching. Tomorrow we'll try to figure out what's wrong with this radio and get it going. See ya.